you can really smell this ozone. Let's now look at some slides. The first slide that you will see is a very classic slide made by Gary Ladd, at Kitt Peak Observatory in Arizona. What I like about this is that these are the observatories, the telescopes in the domes. And of course, when you're an astronomer, this is the kind of weather that you can do without. But nevertheless, it happens. You see here return strokes. The light is definitely due to the return strokes. It's very bright. These are step leaders that never made it to the Earth. And if a step leader doesn't make it to the Earth, you don't get a return stroke. And so the light, as you can see here, is much less. And what you think here is only one bolt is probably at least 10, 5 to 10, maybe 15 flashes, return strokes. All right, next slide, please. Here you see the result of a Boyd camera exposure. For those of you who are sitting in front, you can recognize maybe the Empire State Building here. And the Empire State Building is hit here by lightning at the very tip. That's the sharp edge. That's where you expect it to be hit. This is not taken when the camera was rotating. This is just the exposure the way you and I would see it. Not moving camera, but here you see the result of the rotating Boyd camera. And this is the same flash. So here you see the return stroke. The light from the step leader is too faint. You can't see that. So here's the return stroke, and then this time separation, maybe 30 or 40 milliseconds. See another stroke, you see another one, and another one. So there's 6 here. Looks like you see a double one here. And so you have 6 or 7 of these return strokes. And this is the way that you can study speeds and how much charge actually is exchanged between these, between the clouds, and in this case the Empire State Building. The next slide shows you a corona discharge in the laboratory. This is a high voltage supply. There's a very sharp tip here at the end, a sharp point. And here you see not individual sparks. You don't call this lightning, but this is what you would call the St. Elmo's fire. The corona discharge is bluish light. And in fact, when you are close to this power supply, you can also smell the ozone. It also produces locally ozone. And you can see it. If you make it dark in the laboratory, you can see some bluish light. When I was a graduate student, I had to build power supplies, high voltage power supplies. And I remember when my soldering job was not a very good job. That means when I take the solder iron off, then I could draw a little sharp point, the solder, and that would then later cause me problems with corona discharge. That means I would have to redo the soldering so that the radius of the solder joint would become larger. So no sharp points. That's enough for the slides right now. Benjamin Franklin invented the lightning rod. His idea was that through the lightning rod you would get a continuous discharge, corona discharge, between the cloud and the building, and therefore you would keep the potential difference low, and so there would be no danger of lightning. And so he advised King George III to put these sharp points on the royal palace and on powder houses, ammunition, storage places for ammunition. There was a lot of opposition against Franklin. They argued that a lightning rod will only attract lightning, and that the effect of the discharge, lowering the potential difference, would be insignificant. But nevertheless, the king followed Franklin's advice, and after the sharp rods, the lightning rods were placed, there was a lightning bolt that hit one of the ammunition places at Pearl Fleet, but there was very little damage. And so we now know that on the one hand, the discharge is indeed insignificant. And so the opposition was correct. And in fact, you do attract lightning, unlike what Franklin had hoped for. However, if your lightning rod is thick enough that it can handle the high current, which is 10,000 or 100,000 amperes, then the current will go through the lightning rod, and therefore there will not be an explosion. It will not hit the building, so it will be confined to the lightning rod. And so it worked, but for different reasons than Franklin had in mind, but he had the right intuition. He was a very great scientist, a great statesman, and so his lightning rod survived up to today. So now I want to return to the Van de Graaff and show you some of the things that we have discussed. And the first thing that I would want to do is create some sparks, lightning. I run the Van de Graaff, and I will approach it with this small sphere, small radius, and as I come closer and closer, the electric field will build up here, and then I would predict that if sparks fly over, that they will go between the Van de Graaff and this sphere. The sphere is grounded, and so any current that will flow not through Walter Lewin, but will go through the ground. So there's no danger that anything will happen to me, at least not yet. You already hear some cracking noise. It means there are already sparks flying around inside there. It's very hard to avoid. There are always some sharp edges in there that we cannot remove. This is not an ideal instrument. But I still think I will be able to show you some lightning by coming closer. There we go. So what you think is only one spark may well be several, like these return strokes, the way I described with lightning. So what you're seeing here now is that the electric field locally has become larger than 3 million volts per meter, and then you go into this discharge phenomenon that we described, and that gives you the lightning. What I will do now is I would like you to experience, although it may not be so fascinating for you, to experience a corona discharge between a very sharp point that I have here, extremely sharp, and the Van de Graaff. And the only way that I can convince you that there is indeed going to be a discharge between this point and the Van de Graaff is by approaching the Van de Graaff, and this cracking noise that you hear now will disappear. And the reason why it will disappear is that if I get a corona discharge between the tip and the Van de Graaff, it will drain current, it will lower the potential, and so that cracking noise will disappear. So the sparks which are now flying over will not fly over anymore. You will not be able to see the light. There's too much light here, although I can probably see at the tip here this blue light. So I'm going to approach the Van de Graaff now. It's almost as if I had a lightning rod, and I'm not worried at all, because if any current starts flowing, it goes through this rod, which is like a lightning rod, to the earth. So I'm not worried at all. I just am very brave, very courageous, approaching the Van de Graaff, and I want you to listen to that cracking noise. That cracking noise will disappear when I'm going to draw a current through this sharp point. Oh boy, there I go. And the cracking stops. And I can actually see here some glowing